Hi, my name is Hamza Arshad, and today we're going to cover the topic absolute value, under which we'll do what a modulus function is and different applications of the modulus function. Okay, so first things first, the modulus is basically the magnitude of a number with no sign attached. So the modulus of x is basically the magnitude of x, and there is no sign attached, meaning it cannot ever be negative. It is always positive. So this can, for example, be linked to physics, right? Where we talk about scalar quantities and we say that there is no direction, there is only magnitude. So we do not associate any signs with scalar quantities. So while we have vectors, for example, velocity, we can use minus and plus for them to indicate their direction. In the case of scalar quantities, we do not really associate any sign with them. So that is the similar thing for the modulus function. It basically tells you the magnitude of a number. So you can see here as an example, the magnitude of 10 is 10, right? But the magnitude of minus 10 is also 10. When you put minus 10 in the modulus, it's going to give you 10, and it's always going to give you 10 regardless of the sign of what you're inputting into the function, which is because of the fact that a modulus or the magnitude is always positive. So here you can see an equation that's written modulus of ax plus b is equals to k. So now we know that when there's this modulus sign attached, we cannot have minus k. There is only k. However, when we remove the modulus sign, now there's two possibilities. K is either positive or k is either negative. Why could k be negative? K could be negative because the modulus is positive and the modulus is always positive. So even if you have minus k, modulus of ax plus b equals k will still hold true. So whenever you need to open up a modulus, for example, when you have modulus ax plus b is equals to k, to remove this modulus, what you're going to do is you're going to associate both the positive and the negative sign on the other side. Ax plus b could be k, or ax plus b could be minus k. So that's how you, that's basically the basics of modulus. Okay, so here we basically have an example question. The modulus of x minus 4 is equals to 2x plus 1. So we already know to open the modulus function, we'll do this. X minus 4 is equals to 2x plus 1. But there's also the possibility that x minus 4 is equals to minus 2x plus 1. So you're going to minus the entire other side because there's two possibilities. So for both the possibilities, let's calculate the value of x. Here you are getting x as minus 5, and here you are getting x as 1. So an important thing to do in such questions is also to input the value back into the equation, right? So first of all, let's input x is equals to 1. 1 minus 4 modulus is equals to 2. 1 plus 1 minus 3 is equals to 3. So yes, this is true. The modulus of minus 3 is going to be 3 because basically the modulus is always positive, and even if you input something that's negative inside it, it's going to give you a positive value outside. So let's input minus 5. 5 minus 4 modulus is equals to 2 into minus 5 plus 1. So modulus of minus 9 is equals to minus 9. No, this is not true. And this is not true simply because of the fact that the modulus cannot be positive. The modulus cannot be negative, sorry. So the modulus of minus 9 is going to be 9, and it's never minus 9 because your magnitude can never be negative. So the answer is simply, the solution to this equation is simply x is equals to 1. Okay, so now here we have a situation. The modulus of 3x plus 4 is equals to the modulus of x plus 5. So we have modulus on both sides. So how is this supposed to be opened? Now, there's two methods that you can take. The method that I personally prefer is the method on the left side where we're squaring both of the sides because it's relatively straightforward. As you can see, we've squared both the sides, we get a quadratic equation. We solve the quadratic equation, we get the answer. We get two solutions, which we're of course going to check after on as we did in the previous question. The second thing you can do to open the modulus function is that there's two kinds of scenarios that can happen when you open the modulus of both of these, right? The first scenario is that one of the sides is negative and the other scenario is both of the sides are positive. Why can not both of the sides not be negative? Because simply the minus sign is going to cancel each other out and you're going to be left with positive on both sides. So there's simply going to be two scenarios. 3x plus 4 is equals to x plus 5, or 3x plus 4 is minus of the entire thing, which is x plus 5. And similarly, by using this, you're also getting two values of x, which are 1 upon 2 and minus 9 upon 4. So here you can see that we've checked, and if you input all of this into the calculator, you'll see that both of the sides are equating to each other, and therefore both of these solutions are correct. Alright, so what does the graph of y is equals to modulus of fx look like? First examples being that the fx is basically a linear function, right? So we know that what modulus does is it's taking every negative value and turning it into its positive counterpart. So for example, in the first graph, you can see that this is the graph of y is equals to x plus 2, and there's, I mean, a part of the graph is also in the negative field, which is completely okay. However, the graph of y is equals to modulus of x plus 2. You can see one thing that's happening, and it's that the graph after x is equals to minus 2 is the same. However, before x is equals to minus 2, the graph has been vertically reflected from the original one. And that is because of the fact that each of the negative value is being converted into a positive value. So, the simple rule of drawing the graph of fx, modulus of fx, is knowing that wherever there was a negative line of the graph, that will be vertically reflected. There will be a vertical reflection in the plane of the x-axis, and that will be your graph, as you can see here. One way to write this situation in specific is the modulus of x plus 2 is x plus 2 for x is greater or equal to minus 2, because you can see that greater or equal to minus 2, the line is the same as the original line. It has the same gradient, it has the same y-intercept. However, for x is lesser than x is equals to, for x is lesser than minus 2, you can see that there's vertical reflection, and vertical reflection may in vertical reflection you basically change the sign of fx, right? The vertical reflection of fx is minus fx because you're changing the sign of all of the outputs that you're getting, right? So minus of x plus 2 for x is lesser than minus 2. Here you have another example, y is equals to sine x. You can see that this is like a regular wave with crests and troughs. However, the troughs they have a negative y value. So when you have modulus of sine x, all the negative y values become positive. So the graph of y is equals to modulus sine x looks like this, because all of the negative parts have been reflected in the x-axis or reflected vertically. Okay, so one of the last important things under this heading is basically modulars inequalities. So these are basically rules that you're going to have to learn, right? Modulus of a lesser than equal to b. When you want to open this modulus, this is what you will do. A is greater or equal to minus b, and a is lesser or equal to b, as you can see here. When the modulus of a is greater or equal to b, then this is how you will open it. You will open it into a is lesser or equal to minus b, or A is greater or equal to B. So these are two situations, and these two situations are going to be used to open the modulus function. And it's preferable to remember this. So let's see an example. So modulus of 2x minus 5 is lesser than 3. So we know the rule. If it's lesser than 3, so you're basically going to have minus 3 on one side, 3 on the other side, and 2x minus 5 on the middle. That's a good way to remember it. So we're going to deal with both of the sides separately. We get x is greater than 1 or x is lesser than 4, which can be written as a single line, which is 1, which is basically x is greater than 1 and x is lesser than 4. Here's another more complex example where there's modulus on both sides. I used my preference, basically the method that I prefer, which is squaring both of the sides. So we squared both of the sides, we got a quadratic equation. And as for every quadratic equation, there's two solutions of x, critical values meaning solution. You get 4 upon 3 and x is equals to minus 2. So since this is a situation where the greater than sign is being used, so this is how you will write it. You will write that x is greater or equal to 4 upon 3, which is the larger value, and x is lesser or equal to minus 2, which is the smaller value. If this if in this situation there was a lesser or equal to 0 sign, then what you would have done, then you would have written minus x is greater or equal to minus 2 and x is lesser or equal to 4 upon 3. So there's that. Okay, so just as a brief summary of what we did today, firstly, modulus of x is the magnitude of x. It is always positive. Modulus of minus x is equals to x. Modulus of x is equals to x. Graph of modulus of fx is never negative. Negative part is vertically reflected. And then for the inequalities part, modulus of x lesser equal to a mein, we will write x is greater equal to minus a, or x is lesser equal to a. And x is modulus of x is greater equal to a, we will open that by writing x is greater equal to a, which is the larger value, and x is lesser equal to minus a, which is the smaller value. So this is it for what a modulus function is.